find it disconcerting that you would consider keeping the IPsec text in there with a recommendation when you then turn around and have an update in 5796 that says you can't, no reason to be like text and hey, this is today. We're not doing this and put it in form and 796 saying this is the way I think it should be done. The conflict allows you to point to adopt as something different. You don't have to say about promoting 57. Given that they also implementation experience, that general regional approach.
Yeah, there's text throughout the recommend page. It's not just like the but sure. Yeah. So if you don't do anything, I don't think on that maybe the people and stuff and we will. I know. Yeah. Just that bit. Very confused.
Next to update the big so that and have the level of maturity internet and anymore. We should just test it out. Yeah, one college an informational reference. It's proof that we were personal on other sure and everything be as as roughly recommendation, but we can extra people later that information to it.
So the object graph they mentioned seem to be we have say this one hobby residential doing that that's what I feel that's really like today.
Okay, so in the last full he mentioned that we had mentioned that we could be harder for not some because it's split in the merger. There's been support charter. I've been doing it since as we actually just look at the proposal to the witness or some that look around. I can look the less that it probably be better if we put that around maybe first on the list. So we'll do that on that. Without the shared also part of the reason to reach out for proposed after this, there's so many. So I really trying to open the to and even if there's a time where we think there's a lot of ways to do it, a lot of interpretation at least literate. And also or with the existing starter does say that we may have gone through the guideline, but the review is we are taking it. We make that change. We are also needing to take on the modeling and something we should put in. It was suggested to keep the name as PIM, to not confuse the IETF, the broad IETF. And we're okay with that. We originally thought about renaming it to the MCAS working group so that it would be more broad, but I'm okay with keeping it as PIM. Are there any further thoughts on that?
This is Lucy Young. I actually am in favor to change the name if we want to expand the scope to address different multicast technologies. And the reason is the PIM, the name itself is okay, but in the history, the PIM is now too tied into particular protocols, which now, may be confusing for many people moving forward. So instead of a short PIM, addressing this changing name, we may have if not changing the name, we may have a long PIM to have to deal with.
Earlier Atlas. It's not really changing the name. It ends up being closing and reopening a new working group. You lose your archives. You lose all of the information connecting up to the previous archive.
Now it's not totally clear with the current set of charters where certain new material and that should go.
The only thing I'd say is if you do ever change it, I think something more specific like multicast protocols, because there are other multicast working groups. So just multicast working group would a little too broad, but multicast protocols, and more specifically, any new multicast protocol work.
I don't think it's quite like that. So two pieces. One is, one of the points of the rechartering discussion is to understand what work this working group wants to take on in the next, at most 2 years. It's not to say, and if there's new work that comes up, then you can obviously talk about it. We'll talk about it. If there's enthusiasm, we can recharter to add it in as a small chartering item. We're not going to say absolutely anything multicast related can come in here without judgment. Part of the point of a charter is to keep the working group focused on getting the tasks that it has committed to done. So you're not going to get a charter that says anything can come and we can just decide to do it all. You can have a charter, you can talk about anything you like, that's great, that's related to multicast, but you're not going to see something that says this is where any multicast work will definitely be acceptable and in scope. Right, we have the charter text, but that's not to say that the working group can't decide something's really interesting and it wants to start working on it, and even if it's not one of the items, that we can't recharter again to add it in. But what I would like to understand is what pieces there's actually real enthusiasm for, what work items, make sure that we've got them covered. The IGMP, MLD, including wireless piece that came up as a really good topic, but I haven't seen, and maybe I, a draft or something written down actually articulating the work, that kind of thing.
Yeah, regarding the new piece, I think today we're going to also present this ITP multicast. So if that work item, if that piece is accepted as a work item in this working group, I think it should be changed.
Okay, so that was an interesting discussion. As it stands now, based upon the direction and advice from our ADs, the recommendation is to keep it at PIM. There are some good points to maybe change the name. It may be worth hashing it out a bit still on the mailing list just to make sure, but that's kind of where we stand. Do you agree with that?
Yeah, I agree with that. I was going to say, yeah, PIM is fine, I guess. If someone can come up with a really cool name for a multicast protocol working group, that would be interesting. I think the best we could think of was MCAST or MCAST Proto or something. Anyway, it might be easiest to call it PIM, but I guess that ended the discussion totally.
Yeah, agreed. Okay, so we do plan to finish this rechartering process soon after we meet here. So we're trying to get as much opinion from the working group as we can during this meeting right now. The primary proposed changes include adding Yang models for PIM and IGMP MLD. To include IGMP MLD, including work related to wireless. And there's also a statement that Leah added, which was very articulate with regards to guiding multicast in other working groups without having to take on the work, being the experts that we are, provide that guidance to others. So that's kind of where we're at. But should we include some other things as well, this recharting effort that we're going through right now? One of those that will be presented here shortly is with regards to IGP-based multicast. Something that is a work that has not been welcomed in other working groups, and so we're considering it here. And so there appears to be some support with that time will tell. And it would be good to get some opinions on that now before we actually have that draft presented. The other thing that also came up on the list is multicast over 802.11. And without discussing this with Stig, it seems like with that discussion, it would probably be best to have somebody write up a draft and have that submitted to MBOND, because that seems like it's kind of an operational kind of this is where we see the problems being with multicast in a Wi-Fi environment, and I don't know if that makes sense, or if that's because I don't know if that protocol work would be something that would be done here. It would be done in a IEEE probably, right? Anyway, any opinions on that? So actually, so we have two on the table right now. We already have this proposed charter. There's some other ones that are on the table right now. Let's discuss those right now. The IGP-based and what ages-old issue of multicast in a Wi-Fi environment.
Good morning. I'm Dorothy Stanley at Aruba Networks, and I participate in 802.11. So a question, I had gotten an inquiry about this work and suggested to the person who inquired that if there are issues to create a liaison and send that to .11 if there's more information needed. The question seemed to be if there are mechanisms defined in .11 for more efficient multicast, and there may be differences between what's actually defined in .11 and its amendments and what's actually deployed that vendors have implemented. So, but at the very beginning, there's a need for a conversation about exactly what the issues are, and then we can go from there. So I wondered if there has been any discussion on a possible liaison to .11.
Leah Atlas. Yes, so I did talk to, I did talk, sorry, I did talk to, Dan and other folks who help us with the IEEE liaison stuff, and the idea would be that we would do a liaison, but I'm certainly not willing to do that until someone's actually sat down and written a draft that describes the concerns with 802.11 and I believe 15.4 also. There's two different wireless technologies were mentioned as having multicast concerns. But at the moment, all I've seen on the mailing list is, gee, we should try and fix this without any details, and that's not actionable. And jump on it?
I would agree with what Mike said. If there is energy and a desire and an interest in improving 802 multicast over 802.11, we would probably welcome that work in MBOND. So whoever's passionate and feels strongly, we would encourage you to speak up in MBOND. I think that'd be a good topic of conversation.
So, Mike, instead of now we're discussing whether we want to include this IGP-based multicast, I may suggest after our presentation, because maybe the room, a lot of people don't know about these things. So once we present these things, we can discuss.
Yeah, I agree. That was my intention too. So, then we can also see how much interest there is, how many want to work on it. So, yeah.
Fair enough. So do we have a decent action plan with that? I think as far as Wi-Fi multicast work, I think that's probably reasonable to do that new work. I have some interest there. I'll talk to Torlis, and I know Pusateri and Dino and others had comments on that. Anyway, we'll take it there. And then, yeah, let's discuss the IGP here in just a second. So we're kind of making an assumption that with what was proposed by Aaliyah on the list is people are pretty comfortable with that so far. If you're not comfortable with that, then please speak up. This is the full text. We're not going to just read through it here now, but please do. And we need to, if we need to make a change, we will. This is the time to do it. I think over the next few weeks we should be able to be done with this. So is it reasonable to then talk about Yang and then IGP and then? Sure. Okay. Yeah, we do have one. I need to update it, but that's reasonable. Yeah. Okay. Yeah.
Yeah.
Are the Yang stuff there?
Yeah.
Okay.
Yeah, so I think most of you have heard about Yang recently. There's a lot of working group, internet drafts in the IETF about Yang models right now. I know at least in the, you're not sharing that. I know what's happening. Oh, it asks what to do next.
We just need to do an escape real quick. I had to do that earlier. Yeah. There's an escape on that.
Yeah, there's lots of interest in developing Yang models these days. So at least in the routing area, but I think also in the IETF in general, there's lots of proposed Yang models. So it's for those that don't know, it's more or less to be used with netconf, but not just that, I think. And it's a little bit like MIBS a little bit, but It's basically about how to configure devices and also be able to manage devices, like check the current state of various things. But basically, there's several working groups have proposed drafts. There's also like in the routing area, there's like a mailing list for developing routing Yang models, and there's lots of stuff going on. And there's both vendors and operators that really want to see Yang models really soon. And typical in the IETF or like in our working group, it takes a long time to develop new stuff. So I want to see if there's some ways we can do this more quickly than we normally do. So hopefully people agree that it's useful to have some kind of Yang models for at least PIM sparse mode, maybe IGMP and a few other things. So one thing to discuss is the scope. And does it make sense to have, say, like different Yang models that map different protocol drafts? So say like 4601, whatever is in 4601, maybe should be sort of relate to a Yang model, and maybe BSR, which is a separate draft, could be a separate model or so on, and so on. Just there's some open questions about the scope, I think. We had two drafts actually that were presented last time, a Yang model for PIM and one for IGMP. So those could be starting point for developing further. That's something we can discuss. Next slide, please. What I think we should do, if people are interested, is to form a design team. It's not something we have done much in this working group, but basically to try to get a lot of people involved from different vendors, hopefully some operators, and get a good model that people agree with. I think it would be good to have a broad set of people involved, and maybe meeting, you know, like bi-weekly or something, just to get like quick progress and get models that hopefully the working group would agree with or would have consensus for. So right now, we have two drafts that could be a starting point. I think mainly if we form a design team, then the design team is free to find out, you know, what they want to do, how best to develop models. But at least we have a potential starting point. So main question is, should we do Yang models here? I hope that's a yes. What should the scope be, and does it make sense to have a design team? And then, of course, if you have a design team, who would be willing to actually work on this? So, comments on that? Any thoughts?
Who thinks we should be doing Yang modeling work here in this working group? So I see about 10 hands.
Anyone that thinks this shouldn't be done here, we don't need this stuff. Okay. So are there people willing to work on this that could be interested in actually being part of a design team? If that means working, I don't know, meeting up a couple of hours, like a conference call every other week or something like that. Okay. If you would be interested, or at least consider being part of a design team and work on this, could you raise your hand, please? Okay. That's like five people, right? 6? Okay, that's great. So we'll also try to ask on the mailing list and maybe try to hunt down people from, you know, contact people from vendors that are in the IETF and see if they can find someone willing to work on this. Because I think most vendors actually want this to be developed, and yeah. Okay, but I think if that's like 6 people, and that's pretty good. Yeah. So I guess we should go for the design team plan. But yeah, it's one thing is vendors, but I'm hoping we can find a few operators too, because they're the ones actually that will be using these models. Yeah.
Is this being done in other working groups, this whole gang working on design teams?
I think it's done in almost all routing protocol groups. I guess Alia can comment.
Oh yeah, Atlas. Yes, there's a number of different working groups that either have design teams or have had motivated author teams. ISIS has a working group draft that's a Yang model. OSPF, there's a group of folks working on one. I'm not sure if it's officially a design team. I think it's just an author team. There are several other sort of self-formed author teams. I'm working on chartering a design team to look at sort of the routing area Yang architecture, meta model. How do all of these pieces connect up, and how do we avoid getting good reuse and avoiding duplication and so on? So that may be a group that would be good to connect up to and see what's happening. It is happening across lots of different areas. R2GWG has like 8 different Yang model discussions this time. So it's definitely an area with lots of interest.
So the main concern I have is, well, one thing is of course finding out what exactly in the PIM spec that should be in the model. That's almost the easy part. But the other thing is the overall design of the model. And if we're able to, across the routing area, to have like some common principles, things like whether it's like protocol or verb-centric, whether it extends the interface model or not, and things like that. So the design team, I think, would maybe start out with looking at the PIM spec, but as there is hopefully some common things coming forward in the routing area, then try to make a model that follows those principles. All right, okay, that sounds good, thanks. Yeah. All right, so, yeah. Do we have a microphone? Okay, I guess that, yeah, I guess that's, yeah, he'll do this.
Morning, everybody.
Is it fuzzy? Let me just try again. Yeah, it's. Is there like an auto focus thing on it or something? Oh, there we did. That was good. Just hit this.
Morning, everyone. I'm very here today promoting a idea using ICP to routing for podcast. So I hope that by this talk I don't offend anybody and who think that this group is strictly under pink, because this is such a different approach away from traditional pink for many years.
A little closer to the mic.
Okay. So next slide, please. Actually, I'm sorry.
Is that on even? Can you guys?
Can you check if it's okay?
Actually, this idea using IGP to do the multicast is not a new idea. It's been there a long time ago. Okay. The reason we want to promote this is because the press, some operators, some network segments, and they want to have a simple way to do the multicast. And for example, some of the data center network, right? So when they have their own applications, so that when they bring up the IP, they think the IP is a fabric with the unicast and multicast all together, so they can run the service on top of that immediately without any additional configuration with transient and the people usually do today. And then by doing that, of course, make the network operation and management much simpler, right? So if you can do using one simple protocol to support both unicast, multicast, of course, I mean, by default simpler. And then also, some of the network, actually many, they only do the unicast today because there's no application on top of multicast. And if they decide to move on to support some of the applications using multicast, they will have to additional configuration. So the migration make it easy. And then using single protocol, of course, by default conserve network resource and then promote performance. And also the IGP has been there for what, 20 ISQS was there for over 25 years, right? So there's a lot of operational experience, very, very mature. And a lot of people years ago, if you know IGP, if you know the OSPLS and code, you're expert. A lot of people, graduates, they know how to do that. So this has become a very basic element in the network. So if you're using that to support those, it's very valuable. And also, as you mentioned, the IGP has been there for many years and with a lot of operational experience. And over the past years, right, and the technology still inject to the ISQS OSPF, for example, traffic engineering, right? So that being deployed in many networks today, service networks, including service network and the data center. And also another example, fast rerouting using a loop-free convergence that's further improved the IGP's behavior, right, operation. And then lately, of course, segment routing. There's the new things and innovation keep coming to improve the old protocols. So, and then using the single protocol, as I mentioned, in some of the data center networks, they expecting the IP network when come up, then you already ready for both unicast, multicast, with the hazards. Oh, okay, you put up unicast only, and then if I have an application, you want to do multicast, or I have to do another set of operations. No such thing anymore. You can have the ability to achieve using one single protocol to both, and then the network come up as a so-called IP fabric in the first place. Then the operators, customers, they don't worry about the internal. It's a black box can be used with the operators. Okay, and then it's further the architecture-wise, and we have a separation of the network service and then the network layer and service layer, and it's very clean architecture. So look at the architecture using one IGP, either ISQS or OSPF, to support both unicast, the multicast. There's no magic there. Okay, so you run either OSPF or ISQS, as many in the IP network today is a default. Then you build a link database, right? So when you do that, then you run currently if you support unicast forwarding routing, then you building just pass tree using ISQS or OSPF, whatever being specified, or maybe you want to use your own algorithm, that's fine, right? And then you're building a unicast routing table, download to the line card, and then the strip will support for the unicast, right? The unicast routing. So the same hierarchy can be used to support multicast. Why? Because when you using the same link state database and take that information which has the node and IP address and link information, those things, the network information, you build on top of that. Instead of using short path tree for unicast, you can build another kind of tree called the multicast distribution path tree, right? And then you can start to forwarding the multicast packets. Would it be nice? Yes, I think it's very nice. And then when we do the multicast, we say using IGP, there's nothing being changed in the protocol itself, right? Because the multicast volume is forced within IGP's paradigm. For example, currently, ISQS OSPF, you have a concept of intra-area unicast routing and inter-area unicast routing. When you use IGP to support multicast, same thing, intra and inter-area multicast routing. There's nothing changed in IGP's infrastructure, right? And then the protocol itself, the core of the protocol remain the same. Of course, there will be changes. If we decide to do this kind of thing, then you have to do minimum change on top of the OSPF and ISQS, which is advertise the multicast as group. So that is on top of that, and then both protocol has stability. It's very extendable. And then one thing we have to point out is, using this scheme, there's no change to the hardware. Of course, the hardware itself has to support multicast itself, right? But to using these mechanisms, IDP to do the multicast, there's no additional change in the hardware. Okay, so that's conclusion. And then following through the architecture is just very briefly describe how it works. Actually, I believe many of you know that, right? So it's very, very, very common. So first of all, the edge routers, when we say edge routers, any routers, you have attachment to the IP code, which has the desire to do the multicast transmitting or receiving. So you have to communicate with them as a router, we call edge router, using the IGMP or MID, right? Depending on the IPv4 6. And then after that, you know on your attached level, who are those hosts they desire to receive a particular one or more multicast packets, or maybe they want to send to the network, but you have to build a local table, right? And then in addition, this is going to be we are going to write other draft to extension to ISS and SPF. Those edge routers, whenever they build a local table for the multicast family, local attached, they have to advertise to the rest of the network. Okay, in terms of the IPP is single area, they have to advertise that. Just they do the advertising for the unicast address, the same fashion. All right. So and in the area of the IDP, then every router they receive the same, then they try to do distribution IP multicast distribution tree, and then to forward multicast packets. So in that regard, we mentioned that routing multicasting IDP falls into the same paradigm of the multicast. So in terms of intra-area multicast routing, for CTP routing, you have a bunch of routers, you want to do the same, then they run the same algorithm to distribution tree using the thing state database, which mentioned earlier. And then a root or random point is provisioned or elected, right? So those things can be done, and using the IDP already has that kind of behavior already, similar behavior already. And then all the routers, participating routers, we calculate the optic path to the root, okay, and then building the tree. And then the tree can be further pruned based on is not necessary to forward this particular packet, multi-packet packet to a particular edge router, depending on the description of that edge router's with address. Okay, so this intra multi-packet router. Same thing, similar to the unicast forwarding, you can do the inter-area multicast routing as well. So doing that, we rely on every IDP to every border node, because every border node in that case have to do some function similar to the tree root. And then first of all, you have to advertising selectively based on the policy, advertising to the other area similar to the unicast again. All right. And then when the packets forwarding has to forwarding from one area to the other area, then the border node has to do something special. Okay, so that is the very similar to the unicast forwarding. Okay. And finally, the multicast packets are forwarded according to IGP in the IGP network that we mentioned, right? So we are forwarded to all which are attached to a particular IP multicast address. And then and also forward the packet to the border nodes if they are sufficient to a particular IP address. And then the distributing tree has characteristics. It can be either unidirectional or bidirectional. If it's bidirectional, any lead node in the tree can be a receiver and a transmitter. It's like the regular currently and then if it's a unidirectional, then the root is going to forward the packet to all the nodes in the one direction. Okay. And then another feature that we propose in the architecture is a single distributing tree can be used for one or multiple multicast at the time. And on the other hand, a single multicast address for the forwarding can use more than one tree for redundancy purpose. So this is all built in to the architecture to support the requirement for the forwarding detail. Okay, and then of course we mentioned earlier, right, because the IGP keeps evolving and then with a lot of features there, for example, traffic engineering, right? So if you have video broadcasting, you may consider, to capture the past. Currently, we don't have the ability, but if you have the IGP there, you know the limitation constraint-based routing, you can do that, similar to the unicast forwarding again. And then, of course, the IPv6, everything is available in both IETF and WebPF. So to further demonstrate the ability of using IGP to do the multicast, okay, so we have two examples here, right? On the left side is a bidirectional distributed tree. So we have the rainbow node here, and then all the R1, R3, R4, and so forth. And they can be either sender or receiver, okay? And then for the multicast transmitting and receiving. On the right-hand side is another example, is the tree being built with R2 as the root to the unidirection broadcasting, multicast only. So this is very flexible, can be by default, depends on the operator's configuration, or you can change the default whenever it's necessary. Okay, so the architecture we believe will cover all the needs, requirements for the multicast today running in the networks. And of course, one of the big values we mentioned several times is to inherit whatever the IGP has. The value is there, and the strong experience, operational experience. Next one, please. So this is the end of the introduction of this draft, and there are still a lot of work that needs to be done. And first of all, we select the comments from this working group, and because we respect many people in this working group, they are the multicast experts, and you know what is really required. And also, we asking the working group here to consider to take this work here, and the chair also willing to consider, right? And then this is only a first draft of a serious draft we are considering. Okay, first of all, this draft is so-called architecture. Of course, we still need to fill in a lot of details there, but some of the details will go to a second draft we call solution draft to talk about details, for example, the edge router's behavior, and then some of the algorithm, or the algorithm can be proprietary, it have to be formally centralized. And then, as mentioned, the minimum change to the existing IGP IPS voice behavior is to have to let them to have the ability to advertise the IP multicast address. So that is currently not there, so that can be easily done by extension because we can use your video, whatever, right? So that's the plan in our mind today. Okay, so that's it.
Caitlin Bessler, I'm not understanding how this interoperates with software-defined networking. And it was very common for a data center to set up multiple sets of mutually exclusive subnets that don't route between each other. I'm hearing nothing in yours that recognizes that there are physical networks that have disjoint address spaces and how you would map the multicast in a way that was compliant with how the unicast had been set up.
Okay, I do not know the specific requirement you're talking about, but I'm just purely from the IGP's own architect infrastructure, that point of view, saying that the IGP today, you have intra-area routing, inter-area routing, and if we're using the IGP to do the same thing, do the multicast, then you cannot change the protocol itself. The infrastructure has to remain the same. Okay, so in that regard, then we talk about the intra-area multicast routing, inter-area multicast routing, but I'm not sure this is how to fit into the environment you're talking about. But even though I don't understand, but still, even for the unicast, you have the same problem, right? So
No, it's very, if I'm creating a Coke network and a Pepsi network, all I have to do is only create routes from Coke to Coke and Pepsi to Pepsi. What I'm not seeing is how you it sounds to me like I would have to explicitly limit the multicasting, which would be a lot more work.
right, okay, good.
I have actually many questions, but I'll ask some of them. One is, I would think that as part of this work, we would get a kind of a detailed comparison with MOSPF, so that we know that we're not wasting our time doing the same thing that was already rejected 20 years ago. The other thing is I didn't understand stuff about the rendezvous point and the star comma decrease, right? I mean, I kind of thought you were going to say that we advertise in the LSAs all the receivers we say that there are receivers for a particular group here, and then anybody and that's used to create source trees for that group. Anybody who transmits would just transmit down the source tree. I didn't quite understand where the star G trees came from or what the need was. My pile on, the third thing was after you spent quite a bit of time saying how there was almost nothing multicast specific about this, it's just the IGP, right? You then came to a slide near the end with like a whole long list of multicast specific things that still need to be dealt with. And I guess the fourth, what I think the speaker before me asked is that you don't really say anything about the multicasting that has to go past an IGP.
Can you repeat the last statement? What about the boundary?
Multicast sometimes needs to go past the IGP boundary. And you need to say something about it. I mean, are you expecting people are going to do PIM at the boundaries, right? That weakens the, if you have to do PIM at the IGP boundaries, it kind of weakens the case that you shouldn't do PIM inside. When you need to say something about how multicast is going to go past the IGP boundary.
Yeah, okay, yeah, I think that's a good comment. As we said in the earlier, when we're promoting this IGP, using IGP for the multicast, and we cannot change the product itself, because infrastructure has to stay the same, and we should have the boundary of areas, right? But if you use the IGP to do the multicast, then I don't see what is the importance to follow the boundary there, because the boundary is still being defined boundary, okay? So today's PIN, if you look at PIN, there is no such, it's so-called product independent, right? So it doesn't care about the IGP. I don't think the boundary. That is true, but that is one side of the story. But if you recognize the value of using IGP, then follow the boundary. I don't know what is the overhead, because today you have to respect the boundaries anyway. Because why? Because when you have to do IGP, even though it's independent, it's called independent PIN, right?
Excuse me, two things. Can you hold your mic closer to your mouth? But also, if you make comments, please do it in the mic so everyone can hear it.
Bo Williamson. I hate to throw a wet blanket on this, but as pointed out, this is just a variation of MOSPF. The difference I see here is instead of advertising sources, we're advertising receivers. But one of the major drawbacks that killed OSPF is the need to do Dijkstra repetitively as things come and go in the multicast network. That restricted it in terms of its scalability. Now, obviously, routers have got more horsepower than back in the old days, but there just seems to be several of the old complaints, as been pointed out here, to an MOSPF sort of solution that we hashed out years ago.
Yeah, I remember it was 20 years ago, right? But as you also point out, the CPU today is different. 20 years ago, you have a single CPU, you have to deal with both control plane and data plane. Today, it's a totally different story. And then more than the horsepower, in today's router, you have multiple CPUs. And then in addition to that, the scalability, personally, I don't think is this scheme's own problem, right? And even you're running a unicast routing, and you handle hundreds of thousands of routers, you also have a scalability problem. And then in dealing with that, the simple way is to add more horsepower, right? So every vendor has been doing that. But on the other hand, and the new technique has coming up. For example, if you cannot, you have a limit of the horsepower already on the router, then you can inject, you can prioritize the task, right? So that everybody's doing that. Have injected different multi-topology and multi-instance. There's a different way to improve that. So by saying that, I'm saying that it's not a unique problem for this approach. You running digester, yes, you need a lot of horsepower, right? And then one of the points is you only do the calculation when initially and also when the topology is changed. And the same thing for the unicast. How many times you have to do that, right? So, and adding more horsepower is one way to do that, but its other techniques can be also added. Then again, it's not a unique problem for the unicast.
Lucy Young. Yeah, I'm a co-author on this draft as well. I just want to answer some question. I think that I hear a very good comment early on by Christy and also the Eric. I think some things is good. That's why we wanted to develop this architecture work, make sure we're seeing what kind of necessary requirement. But regarding some comment you had concern about this multi-tenant environment, how you provide security, those things, those kind of addressable. That's one of the primary use case for this one. It is used for the data center environment, and we want to make sure how to use which tenant the multicast group can be mapped to a particular trade, and how you can provide security, segregation, all those things. And also regarding this, the cross-domain things, as Eric pointed out, currently we are here talking about the multicast within the IGP. But between the IGP, you go to the inter-AIS, sure, we can, if we have this solution, we can develop a further solution how to the cross border. I think those things can be addressed if we are, see this is valuable, let's work on this, then the all solution the technology there can be used to solve this problem. So that's just a general comment. Where this is just initial architecture draft, we are certainly want to, expand to cover all the necessary requirements.
Is from Cisco. So you use the link-state database to build a tree, right? And then you're going to map multicast traffic to it. But you haven't really explained how you're constraining the multicast traffic. Like, once you put it on the tree, it goes everywhere, or do you selectively forward based on links that only need to carry the traffic?
Yeah, the reason to build a tree is to only forward the packet is necessary.
Right, but that means you build a tree for each multicast flow. Right, because that's not clear from what you're saying here. You're saying that SPF is used to build a tree from the root to the receivers. But if you have multiple flows for each its own receiver that's set, you need multiple trees for each flow.
Yeah, okay. Maybe the slide's not clear here, okay. So, when you forward the multicast packet, it's supposed to be the tree, right? So, there could be a default tree, and they're using the same tree forwarding all the packets, but we can do pruning. And if this edge router, there's no subscription to a particular multicast address, you don't have to forward.
Right.
So that's one option. The other one option, the extreme of that option is every multicast address you build a separate tree. You can do that too. So it's actually partially expanded the scalability problem, right? So you don't have to say you have 100 or 100 multicast address. So the worst case you have to build 100 tree, but that's only one option. You can build 50 trees, 30 trees, whatever.
So it sounds a lot like MVPN, right, where you have default entity and data entities. But if you want to be like Is
But
this
protocol is the same,
is that
just using different protocol.
right? But the thing that you know that trade-off between state and flooding, right, is not a good trade-off, right? Because you're just pushing that problem into the customer's hands now, right? Just by providing this option doesn't mean that's a good thing.
I'm not sure what I mean. Push the customer into which state?
So just giving that option, like, well, you're not solving the problem. You're just giving the customer, say, well, you choose one of the worst, you know, one of the cases, right, that you prefer, but it's not really solving that problem versus state versus flooding. So, but assuming that you create state and you have efficient distribution, that means you have just as much state as you would have with PIM. Right? So I don't think this makes it any better than, for example, that you do with PIM. And there's one concern I have actually also with, if you want to announce the membership, the groups have membership in the IGP, that membership information goes through the whole network.
Yes, that's true.
Right? Now, with PIM at least, right, it's only confined to the tree that you're building. So only part of the network has to deal with the join information. And now the join information always goes everywhere, right? So that's an additional scalability concern compared to PIM. So I don't think what you're doing here makes it, in the end, when you're done with all the corner cases and all the stuff that needs to be solved, you end up with something like PIM, I think. It's only using a different distribution mechanism using the IGP.
Yes.
So you say that like, well, this is IGP unicast and only need a few extensions for multicast. Well, those few extensions that list is quite long, I think.
Yeah, the topology using the ISS or OSPF is built in a mutual way. It doesn't have to be right?
Well, but I think a lot of the features that you're explaining here is all specific to multicast. You're not going to share anything that for unicast.
Which one?
All the functionality you're talking about here
Yeah.
is something that is done, it will have to be done for multicast specifically. It just sits within the IGP protocol,
Yes.
but it's not reusing any unicast technology there.
No. Yeah, that's Mike, can you put the I think it's the one with the diagram? Okay, this diagram, right? So this protocol itself today only used for unicast, right? And then if you read this is very neutral, nothing to do with unicast, because one of the basic things that the protocol is doing is building the link state database. Link database is a topology network, and today, of course, on top of that is the unicast address attachment, right? So with that information, you can build a shortcut path tree to support unicast. So all we're saying is, okay, you have network information here, you have a unicast address attachment. How about add one more, multicast address attachment? Then you can build a separate tree, okay, to forwarding multicast. That's the idea. And you don't have to change the core of the protocol, right?
Yeah, but that's not, you say that's it, but that's it is,
That's what?
that little thing you say, well, that's it, right, that you need to add, that's a big thing. Let's say, PIM also relies on unicast routing, right, so it picks up the topology for unicast routing. That's what same thing here.
There's a dependency on the unicast?
Well, but the only thing is PIM gets the unicast routing information through the RIP, right, where other IGPs put information in. So PIM has a dependency on unicast routing, which is similar to this, really.
I don't think there's a dependency on. Are you talking about dependency on the unicast?
Well, on the unicast routing protocol, right? PIM is independent of any
today,
IGP.
Yeah, today this protocol is considered a unicast routing protocol. So, but if we can, what I'm trying to say is, you look at the detail of this protocol, all the collected network information, the node identify what routers, and then it can connect between them. So that information can be used for both unicast and multicast routing. That's what I'm trying to say. But that information is not enough. You have to, for the unicast forwarding, you have to have the unicast as attachment. Where are those addresses? Subnet. So those are being advertised by the protocols. So what lacking, if you want to use this to support multicast, then you have to add one more thing to multicast attachment. All right? So these two things are side by side. Only one common thing, the network topology information are common. But the address attachment, of course, different.
So one more comment, and I'll give it to Lenny. Here he's just picking up the unicast information earlier on from the latency database, right? That's what you do here. PIM will get it from the RIP, right? Where the conversion information is put in the multiple protocols. So in that sense, it's not very different. But we can talk about afterwards if you want.
So Eric took a lot of my questions, but I don't think I heard answers to them, so I'll kind of ask. One, if you're flooding this information throughout the domain using the IGP, why wouldn't you flood the source information? Why do you need rendezvous points?
For the address. What information are you talking about?
Why wouldn't you, if you're flooding information about the groups,
Yes.
why wouldn't you flood the source information so you don't need rendezvous points? Why do you have rendezvous points?
The flooding the multicast, the group address is to understand where are those leaf nodes for the distribution tree, so that the forwarding those.
So you're flooding receiver information. Why wouldn't you also flood source information? Then you can get rid of rendezvous points. Rendezvous points are not good. You have to send packets to the rendezvous. The source has to send packets to the rendezvous points. The rendezvous points have to talk to one another, use it somehow with MSDP or something like that. If you're going to use the IGP, why not use the IGP and get rid of all the crappiness of PIM?
You mean the advertising the standards, multi-standards address?
Yeah.
Address?
Yes.
The unicast address?
Yeah, why not?
Why do that?
So you can get rid of rendezvous points.
I can maybe comment on that. I think if you do the source information, you could do optimal forwarding. The problem though is that there's more state and there's more computation. I think the idea.
Haven't we crossed that Rubicon with this? If
Right.
you're going to have your IGP carry group information, receiver information, why not carry the source information?
Sure, but I think the reason for having a rendezvous point is that you can have like this sort of like shared trees. So there's like a common tree, so there's less computation. So it's like a trade-off between how much state and how much computation, basically.
But the whole point of this is we no longer care about computation because MOSPF essentially did all this 20 years ago, but it couldn't do it because it was too computationally difficult.
Yeah.
But now, 20 years later, we can computate things, but we're going to only computate some things because we're worried about computation. I guess I'm not following.
Yeah, I agree. If you take it to the, if you take it to the full,
Either you care about
State
computation or you don't
Yeah.
care about computation. It doesn't make sense to say we half care about it for the receivers and don't care about it for the sources.
Well, it all depends on how you forward the packets, right? If you're forwarding using tree, then if, for example, for the unidirectional, the flow is from the source, or maybe from the root to all the leads. Then all these routers in the supporting routers in the area, they have to know where are the destinations. It's similar to the unicast, right? So if I'm in the route in the middle network, I receive a packet, I have to know where to send it, which outgoing interface I have to send to. Then I have to know where is the subnet is. This is similar to the multicast 2, right? So that's why you have to, as a route in the middle somewhere, I have to know where is the destination. And the attachment of the address to which router, which we call the S router.
Right.
I don't know,
Yeah, I mean, you're just saying that you need to flood the receiver information. I'm saying why not flood the source information while you're at it? Yeah. I guess, so my point is, the shared tree is pointless today. If you can get rid of the shared tree, get rid of the shared tree. Nobody, generally speaking, people don't desire to have shared tree forwarding. They have shared tree forwarding because they had to, because PIM couldn't deliver source information everywhere. But now you're using a protocol that can deliver source information everywhere. Get rid of shared trees. Shared trees are bad.
It used the microphone, but if you want to comment.
The other question was, how is this different than OSPF, MOSPF? Why would it succeed now when MOSPF didn't, other than, processors are faster?
to be honest, I don't recall the details of MOSPF, although I was halfway working on implementing MOSPF at the time. But we don't pick up something which is useless, right? example, data center. When they're bringing a network there, right? So everything's there. They consider it's a fabric, right? It's infrastructure. And then the early days, multicast is, may I say, is a little bit fancy because at that time there's no application multicast. So how many networks, 10 or 15 years you have network running and the automatic pings there? I don't think many are there, right? So now the multicast is considered as is some of the primitives there. So you bring up the network that everything is there. And in that regard, there's a difference, requirement difference, right? And then the other thing is, MOSPF, just like OSPF, if you read the RC as a Bible, you basically translate English to C code, right? So we're not going to do that, right? Because we want to have the algorithm is not standard based. You know, you can do whatever you want, but the concept is using the IGPs, build a database, and then you based on that information and plus a little bit extension to propagate the multicast attitude, then you have enough information to do whatever you want, right? There's no, I don't think we have to propose any standard-based algorithms. Okay, so then it's quite very different than the MOPF.
Hi, my name is Uma from Ericsson. I'm talking from IGP standpoint of view here, and I like this proposal, and I also gone through the MOSPF. We have a good data on MOSPF, how things are proposed 20 years back, and where we need to improve on. We have basic setup in MOSPF. This is not being deployed because not many implementations were not there, and there are no requirements 20 years back to have unicast and multicast on the same protocol to be deployed like data centers we have today. So for that matter, MOSPF is the guide for us to guide us, and the drawbacks what we have 20 years back, we should address in this architecture. For example, RP shade tree is a good advantage here actually. MOSPF doesn't have RPs. So for your comment, actually, we need to see. We have a lot of computing users now. Let's not waste something, right? Like whatever need to be done, we need to do that actually. So in that sense, we need to see from MOSPF point of view, what are the architecture points we need to take and move forward, and we need to see if IGP advantages, what is being advertised here, can be leveraged on the data center networks. We should leverage it, and it is accelerates the deployment, and it eases the operations in data center networks.
Anup Ganwani from Dell. Just a few comments here. So I think there's probably some amount of misunderstanding with respect to what your proposal does, just judging by the comments from people. And I don't know if there's a better way for you to clarify what it is you're doing. But I think basically, if I understand the proposal correctly, you're building just one tree, and then you program the multicast state along the paths in that tree for a given flow, right? Is that correct?
Yeah, building one tree or more trees.
Right.
If you're concerned about the horsepower, then you build less trees.
Right.
If you have more power, you build more trees. You know, that's just like unicast, right? So if your router is not powerful enough, then you can support only 100 routers, 100 nodes.
Right, I understand that.
So that's the scalability problem is can be overcome.
Yeah, and so if we try to sort of like articulate why we think fewer trees is better, that might be something useful. So like, for example, if we're targeting this technology for data centers, because the data center topologies are very regular, you only need to build like a few number of trees. You don't have to build a lot of trees, even for optimal forwarding.
Yeah.
I just have to build a small number of trees.
Right. Yeah, maybe I'm confused. Let me emphasize here. You're building, of course, you used to have one tree, right? Okay, so one tree for every multicast address group. You can do that.
Right.
And then you can have one tree per address group, or maybe multiple trees per, you know.
Right.
If you have multiple, then we said maybe for redundancy for the switching over, things like that, right? But
right. My point is like if you have a regular topology like a clause topology, the number of trees you need is equal to the number of spine nodes. You don't need anything more than that for optimal forwarding. Right? And so like even if you have 10,000 flows, you just have, you know, and you have 4 spine nodes in a clause topology, you just need 4 trees and you can achieve optimal forwarding. I think it would have been good to sort of communicate that point so people understand where you're coming from. Yeah.
Microphone.
Just having a few trees, right, but 1,000 sources. Are you going to send all those 1,000 sources over those few trees?
Yeah.
But that means that packets go everywhere, even if they don't need to go everywhere.
They get pruned based on the destination membership information.
But then it's a single tree, but still with a lot of state on top of those trees to prune the information.
There is state on top of those trees.
What is the difference between state on the tree and the tree itself? I think that's the same thing.
Yeah, that may be a valid concern there. So now I lost my train of thought. Yeah. Yeah. So that is a valid point. Like with respect to the amount of state in the network, that this proposal doesn't help that in the sense that the number of forwarding entries that I expect in my hardware would probably be the same, regardless of whether I use PIM or whether I use this approach.
Yeah, I wouldn't say that it's stage, right? So the question is, do you have a stage in the unicast routing table here? I mean, in addition to the protocol's own neighbor state, there is no additional state. So whenever you check the routes using the tree, then you download the routes to the hardware, then you're done. There's no state there, right? If you want to say like the word called state, then the state is the route, then it's on. The route is on. It's active. Otherwise, it's not.
Right. Okay, and the other thing is I think some other folks commented on, you know, like what happens if this needs to leave a given IGP area. I think that is an important problem also. It needs to be addressed.
Yeah.
I think before the working group can say, yeah, this looks interesting, they probably need to see the big picture.
Yeah, thanks for that comment. Actually, the boundary problem, well, we feel that because you're using the IGP, right, it's not a brand new problem, right? So like a ping years ago is a new problem. It's independent. It's nothing to do with IGP. You can define your so-called ping domain. Now here we're using IGP, then we cannot change the protocol, right? So you stay with what it has. But however, the IGP actually can cover many areas. You have inter-area, between the AS, you can do the same thing. So if you have the need to build a multi-gas forwarding tree across all the regions and then across the boundary of the AS, the area, you can do the same thing. Just like unicast, right? So if a big network, then you have the need to divide into different areas, different AS, then you can still do the forwarding of the unicast. Same thing for the multicast.
Right. It's just, I think, sort of, even if that's obvious, it probably needs some detail.
My understanding is the boundary there within IGP is for the IGP's own scalability, scaling purpose.
Right.
It doesn't prevent you from forwarding packets to other regions.
So I think we need to stop the technical discussions soon. Well, we'll let the people in line finish what they want to say, and after that we'll talk about, you know, what we should do with this in the working group.
My last comment was with respect to kind of, you know, the amount of computational horsepower that's needed. So at least the way I see it, it's less than what something like an MOSPF would need if you were taking account of the topology of the network. So like the case where I mentioned, if you have like 4 spine nodes, and so you just have 4 trees, and it's a regular class topology in the data center, you would only be computing 4 trees, and you only run Dijkstra's when a link in the network goes down or comes back up. You don't run Dijkstra's when when group membership changes or when new members come and go and so on.
Actually, that's
right?
a very good point. Because the intention here is we don't want to standardize the algorithm. Okay, there are many algorithms. Okay, in my experience, is different people, different companies do it. Even within companies, there's different algorithms to do things, and algorithm can be very advanced, as you mentioned, right? You don't have to when you build a tree, you don't have to every time from the starting point. You don't have to do that. And,
Right.
and as how to do that is nothing to do with draft, right? You can do whatever. It's implementation issue.
Right. No, but I think there's some confusion in the sense like folks think that when you pass around group information, every time a group information changes, you have to run a Dijkstra, which is not true, is at least based on my understanding of this proposal.
Yeah. I know that you don't have to run from the beginning.
Right. Okay. Thanks.
Thank you.
Jeffrey from Juniper. So a lot of connection has been made to MOSPF, and your counter-argument mentioned about source tree versus shared tree. That's really not the key. The key is that it's in concept is still the MOSPF concept, and it still has the old problems. The computational problem may not be there, may not be that bad anymore, but the fact you are flooding the group membership everywhere, and that is still a big concern, especially when we talk about in the data center scale. Someone said you need tens of thousands of groups, and you flood that much information everywhere. That's still a big concern. And also the area boundary issue mentioned earlier. That's another problem. The motivation for this one reason was mentioned was that people don't want to run another protocol. Well, if a data center operator really cares about the multicast. I know that some don't care. If they really care about multicast, today's PIM implementation and the protocol, SSM and SSM and PIM BIDER are very mature. It's not difficult. And also, if you really don't want a PIM at all, you want to standardize on a single protocol, then you do not need to flood your membership anywhere. You can still just use the OSPF like link local flooding to do PIM kind of things. Just send join prone message. That's another way to reduce the flooding. And finally, I think that in data center typically is a single vendor. So as you said, you don't really need to standardize anything. You just implement it and make your customer happy. And then if this practice gets popular, and then everything will just happen, not like what VXLAN happened. It didn't happen in IETF, and now it's become very popular.
A lot of your comments about scaling, I think, are missing the point. It's very common to have multiple tenants within a data center. They are not interested in the workload on the router. What they want is address isolation. It would be very common for people to have their addresses be unicast visible, but for them absolutely have no desire for their multicast addresses to be visible. That is, they're running their own private networks. All their private networks connect to the internet. They don't expect their multicast traffic to go to the general internet. At minimum, I think you need to recognize that there could be a very deliberate, simple policy decision that has to be enabled to limit the scope of multicasting to a specific set of unicast subtrees.
Yeah, actually, that actually is a very good point. Actually, however, I feel that the separation, the address space is simply to separate the topology, right? Today we have technically even for the unicast, right? You can have multi-topology. You say, okay, this topology only for unicast. You can run the same protocol with a different instance, different topology. So this is for multicast. And would that satisfy your separation? There's at least one way to do that, right? So if you want to do multicast, the multicast address has to be somewhere in the network anyway. You want to hide in it, and you want to separate from the regular unicast network, then you can, if you're choosing
Okay, we need to move on. Do a quick comment or?
Yeah, I mean, it was already bad enough when MOSPF was done, but nowadays, there are more unicast protocols, right? I mean, there's Babel becoming, popular through HomeNet, there's Ripple becoming popular through IoT, so, even if all the other arguments as other people made here on the microphone line were ignored, it's just, it becomes more fragmented, right? I mean, one of the strengths of multicast has been that we have been independent of whatever bloody unicast routing protocols people chose, right? So I think, the fragmentation alone is what I would be worried about even before thinking if anything on the technical side would have changed, which I don't think, right? Just more CPU power doesn't make operations of, a complicated solution not easier.
I'm unclear as to what problem you're trying to solve.
The problem is to, like we talked about, the requirement in the data centers, for example, they want to have a unified IP, social IP fabric or not, and unicast and multicast, the capabilities are already there. You don't have to do additional configuration. And that's the first thing. And the second thing is, if you can achieve using one protocol to do both, then a lot of simplifying the operation and configuration effort.
Okay, just two more comments.
Because we have something running already, even though it's not optimized operation, but if you get used to it, then the tendency is to stay with that. But we usually don't want to promote something which is useless, right? So there is a demand, at least from some of the operators that want to have, for any reason, for example, they don't have the ping operating experience. They are IGP ready for years, and they say, hey, I want to support some application using the multicast. Then they probably will love it. But somebody they already using the ping for years, and why bother? Okay, so the bottom line is we are not going to do the replacement yet, right? So we're saying that this option can be used in case that for any reason the ping is not there, or you want to use ping for any reason, but this should work. That's bottom line.
I just want to point out that I think this document basically is a very primary architecture document. We set up this way. One thing that we have this ITP architecture allow us to develop some multicast solutions. Really, we're not have include detailed solutions, but here we're discussing a lot of technical solutions things I don't think really covered. Actually, we are want the people work together on those the solutions that fit today's environment, fit today's requirement. And point out that there's a new point since for the data center, the network which have a special topology, which is a primary use case we're targeted for. And I fully agree with data center environment. We only need a few trees, and all the multicast group can share the same tree. Then we do able to have some solution which can provide optimized forwarding, so you don't avoid those kind of flooding the packet to everywhere. So those are really the solutions we haven't really touched, but people I think here have the technical background and just start to imagine it and speculate. So I hope we can focus on this. This is the direction we want, the motivation we want to do. And also this security things in the data center, support multi-environment, as we're saying, that's also have solution available. And the last point I want to point out is this the MOSPF that's being developed, proposed 20 years ago. And since PIM win that game, so that development is fully stopped. Then after this 20 years, this IGP network has enriched a lot, have a lot of the new features which can be benefited for the multicast, but really we're not utilize that. And also today's market requirement also changing, especially as we're seeing in the data center. We want this kind of a automatic self-established network supporting this overlay, the virtual network. These requirements is not in the 20 years ago, same as when we developed the MOSPF. So those are the requirements motivates us saying now IGP-based multicast is necessary. It's become the mandatory, not the optional anymore for certain the use cases. That's why we want to do this work.
Overall, the argument that it's one protocol as opposed to two, I guess I understand, but a rose by any other name would smell the same. If you take the functions of one protocol and shove it in the other protocol, you didn't make anything operationally easier, you just renamed it. And that's essentially all you're doing. It's not about the goal of one protocol as opposed to two. It's the functionality of these protocols. And if you just take it from one and shove it in the other, you didn't make anything easier, more operationally simpler. You just renamed it.
Can we?
This approach is not to take stuff from another protocol to this one protocol. Okay? Because we do not make any change in the existing IGP except those minor extensions we propose. We want to do that. Okay?
But no changes except for these changes is changes.
But this is about the PIN, the RC, right? How many pages there? You have a lot of details. How to do the handshaking, how to do the join, how to maintain the state. Those things are not in the proposal here. We don't know that.
Well,
That's why
ultimately, you end up reinventing PIM and sticking it, because once you consider, well, what about this corner case, and why not this, and how about interdomain, and how do we connect these rendezvous points together, and how do we, get the source, at some point you just reinvented PIM and you just called it your IGP. So I guess my point is, if you're going to use a new protocol, make it better. Don't just try to copy the existing functionality and say it's easier. You have OSPF can do things, and PIM and ISIS can do things that PIM couldn't do. Why not take advantage of those things to make it better? For example, flooding source information. Then you can get rid of shared trees. You can get rid of rendezvous points. Instead, you're replicating the crappy functions that PIM had to do, and you're just moving it into another protocol, renaming it. And you can say there's no changes except the changes. So ultimately, you end up, when you add up the pages in the RFCs of this plus OSPF and ISIS, it'll probably be roughly similar to the number of pages in the PIM RFC.
Let me respond to a number of things. Okay, first of all, I want to emphasize, we are not copying anything from any other protocol to this approach. Okay, as you noted, we only propose, the draft is not looking in, to advertising the multicast group address as extension to ISS to OSPF. That's the only thing we require to change to the protocol. There's nothing else from PIN or any protocol to be copied and moved over. Nothing. Zero. Okay? And second, I would say, okay, the calculation of the tree, in my view, is outside the protocol. Right? Even though the OSPF 2328 has a detail how to build a tree. But I know a lot of people may think they didn't follow that. Okay? And the other protocol like the ISIS and the PNI, they don't have anything to tell you how to build the tree or how to calculate, how to run that itself. So maybe it looks like similar or even the same, because to forward the multicast package, you have to have a tree. That's a common part. Okay, the PIN doing that, if we use this, you have to build a tree. The tree is similar to the PIN, but the tree itself, the tree build itself is not part of the protocol. So in that regard, I don't think we are copying anything. Okay. Number three, you say, okay, if you invent something, we're not inventing anything, right? We in the existing protocol do more things, right?
That's inventing.
That's inventing? Okay.
Absolutely.
If you say inventing, then a lot of details, this is just the first step, can be added in. So you suggest you don't use shared tree. Yeah, we don't say we have to use shared tree. You can say, okay, we can advertise the center. If there's a need to, we can add to the advertisement, we can do that. That doesn't prevent from doing that.
So trying to end the discussion, I was crossing the line earlier.
I promise I'm trying. Hi, I'm Greg, Cisco. So let me step back just a level. The IETF is not an infinite pool of engineering resources. We'd like to think we take on new work with the intent of improving the art.
Now, ultimately, I'm happy the conversation's taken place, but I do feel much of what has been presented a bit is disingenuous to say no changes to the IGP except, and then there's articulation. So there clearly are changes. Let's be honest with that up front. I'm glad the conversation took place, and I would like to see you come back with the solution in detail and not just bullets, and so that we can honestly evaluate it, as opposed to like today with lots of time has taken place and a lot of information has been given, but I don't feel like there's been an absorption of the community feedback in a way that we can evolve your solution to further evaluate it.
I think that's a good point. And personally, I have to admit, this draft is what we call architecture draft, but lacking some details. One reason is we think that some of the solutions have to go to the other solution draft. That will provide much more details, right?
Yeah, those details are falling into the category of, and magic happens here, which is all the magic of PIM, of creating and maintaining state. As somebody that's traveled around the world teaching people multicast, what I hear over and over is the thing that initiated the discussion that you have about maybe doing something with unicast, and that is, I understand unicast, I just wish multicast would just work, and I don't understand it, and it's too hard for me to understand. That's what's driving the requirements from your customers. The problem is, even when you take this to its conclusion, with all the state maintenance and everything that goes along with it, all you've really done is change the signaling mechanism of who the receivers are and extended IGMP into the IGP, and that's a far cry from generating multicast. So in the end, you will have something that's probably just as complicated for people to understand, but has all the other restrictions that we've encountered in MOSPF. So if you're going to keep on with this, we're going to have to see a lot more details as to how you're doing this, and my opinion is you're going to be right back with the same level of complexity when you hand it over to your customer and they go, wow, this is complicated, that's not what I wanted. Well, I guess what? Nothing difficult was ever easy. And they don't ever understand that, and I run into that all the time when trying to explain multicast to people.
Okay. So, personally, I think that we are going to work on more details to make the details more visible and with how these things be worked out. And the other thing is we have to also look at the history. What was the problem with MOSPF and during comparison, and see if there is a similar thing that existing in this approach, then how we overcome that given today's technology. All right? So thank you.
All right. So I think that the main thing we should consider at this point is whether the working group wants to do work in this space, whether something in this area should be part of the charter. So I would like to see what the interest is in the room. Maybe first of all, who has read this draft? I was curious during the discussion if people actually read it. But okay, that's not bad. Yeah. So how many of you feel that the working group should do work or explore, the space, like how to use IGP for multicast, do some kind of signaling as part of the IGP and basically explore that area. Not this particular draft necessarily, but this area. I know that's kind of like an open question, but just want to see some kind of, what the level of interest is.
Because we're trying to decide whether to include it in our charter or not, so that's why we need to get your feedback. Okay, so we see some hands. Keep your hands up, please.
9.
9.
Again, 9. How many people think that this is a no-go? It's not worth spending time on looking into these kind of solutions. It's 10, maybe? Okay, so the exact number doesn't matter, but at least the group is fairly divided, it seems.
The binary choice is kind of non-satisfying to me, right? I'd love to see a reinforcement of kind of the direction that we've taken, why we haven't chosen the IGPs, right? Because I think we spent, an hour or so about that, and I think, there are a lot of people outside the IETF which may have forgotten the history, right? So I mean, if we spend time, I'd rather have it, on something that actually, re-summarizes that, right? We've seen in other areas where people are stepping back and saying, hey, we have a lot of technology, people don't understand why we've made these choices, how they're best being used, and maybe this is exactly the area that of problem in multicast, right?
Yeah, so I think we need to, we can't, make any decisions right now. At least there's like a, big split. So I think, we can keep discussing the idea on the mailing list and see, and well, provided we have time, I don't mind, maybe spending some time on it, like in some future meetings either, but at least right now it is fairly divided. So I think people that are in support of this idea need to, try to find some ways to explain why this is better, see if you can convince some of the people that are against it.
Yeah, I think that as the questions, as the choices were presented, I don't know that that's, so I think it's worthwhile to look at what's the best way to do multicast routing. And if there are better ways to do it than PIM, maybe through this protocol or that protocol or another protocol, I think that's worth exploring. So for the purposes of the charter, I think we should have the ability to explore alternatives to multicast routing that aren't just, it's got to be PIM, it's got to be called PIM, it's got to use PIM.
Yeah, at least
I think it's worthwhile to look at those things.
Yeah.
In terms of this specific proposal, I find it underwhelming, and I don't know that it's ready to. This proposal doesn't meet the burden of, hey, let's explore this, because I don't see the benefits outweighing any of the costs.
Right. Yeah, I would say at least the way we are thinking about the charter, and we've been discussing the ideas, and we're trying to have in the charter is basically, we are open to do multicast protocol work, and we are happy to explore pretty much anything within, certain limits. So every PIM meeting, I'm hoping we have time to, spend some time exploring new ideas. And if there is something that, has lots of interest, then we'll try to get it into the charter.
Yeah, I think that's good.
Okay. If you don't mind, I think that's a brilliant point. So I've got your back. So let's ask the question just a little bit different. Just again, we're just trying to get this darn charter finished. So who would, based upon what Lenny just described, who would be in support of us adding something to our charter that includes working on alternatives to existing multicast routing protocols? Okay, so we've got, I don't even know how many hands we've got, 20 hands or so? Okay, that was, yes. Yes. Yes.
Hi, Alvaro Rotana, Cisco. I'm sort of channeling Aliyah right now. I would say that the way the charter is written right now already includes exploring multicast related things. I think that includes alternatives, includes enhancements, includes anything, right? Specific items that we want to call out in the charter, specific work, like the Yang models that are in there, are going to later translate into specific milestones that we're going to want to have something. So I would say that unless we have a specific item of work that we know we're going to deliver, we probably want to leave the general gist of the charter as we're going to look at multicast issues. It may be replacement, it may be enhancement, it may be whatever. And when and if there is consensus in the working group to adopt something, sure, now we can go and add the extra sentence that says this specific work we're going to go do. But I don't know, unless anyone today has another idea for replacement, I think that the general charter is probably okay.
Okay, I like that, but I don't think we currently have in our existing text anything that allows us that flexibility to, it may be implied, but to explore alternatives to IP multicast routing protocols. Maybe we should just add a sentence to that.
So we just need to make sure that the charter is not limited to only the options that are listed, but it's general, meaning that, that's why the discussion at the very beginning of, the name or not, right? Because the intent is that we want this to be the place where multicast comes, right? Or as you said, also where you go and lend multicast expertise to other working groups, right? So we want to make sure of that.
Okay.
So if the charter is not clear there, we can, add some words or do anything along those lines.
I think, yeah, that's great.
I agree, and that makes sense to me. And at least the way I'm thinking about it, we have certain charter items to have some kind of focus, and we, those are the most important things. But at the same time, we want to have some time to explore and possibly come up with future charter items. All right, so at least the way it seems to me, we're not ready to add like specific IGP work to the charter right now, but we can keep having the discussion on mailing list. We can try to have some discussion in this area next PIM meeting as well. But at least right now it's not sufficient support added to the charter.
I agree. Yeah, just thank you, Dean and Lucy and others for allowing us to discuss this. It's been fun, actually, and we'll see what the future holds. But I think at least we'll be able to add something to the charter to make that possible.
Yeah. It's kind of nice to actually think about different ways of doing multicast and not just like minor improvements.
Yeah. All right, I think we're up with cards.
All right, so next agenda item. Maybe I should say this is also, not in the charter now, but it's something we can consider adding to the charter if there is interest.
Okay, thank you. So my name is Carlos Bernardos from University Carlos III of Madrid. I'm presenting this document, this drafting on behalf of my co-author, Luis Contreras from Telefónica. This is a work we have been trying to get in different working groups that originally come from a mobility working group oriented, multimod, where we identified the need of maybe discussing again, because this is not something new that was discussed years ago in the Magma working group, I think. And it's the need of extending MLD proxies to support more than one upstream interface. Next, please. Oops.
Oh. I don't know.
Anyway, where this is the proposal status. So the current document basically tries to identify the need of having this MLD proxy with multiple upstream interfaces by having a kind of problem statement section, then the motivation of why we should be doing this with extending MLD to support multiple upstreams interfaces. Then we identify some use cases where we think that extension will be helpful. And then the last part is trying to, out of those use cases, identify some requirements for the MLD upstream interfaces that will need to be worked out in a solution draft that is a different document. We are not working on solutions yet, just requirements. So next, please. So this is the kind of the problem statement. So basically the idea is that we want to support multiple multicast content providers on a common on a common access network, and the idea is to be able to allow the subscriber to get the preferred content from different content providers without requiring all the complexity of having multicast on the aggregation on the access network, multiple routing protocols, sorry. So just having MLD. And it also provides some kind of way of redundancy in the provision of the multicast content. Next, please. So having that kind of a scenario, problem statement scenario in mind, the motivation of using MLD proxy is that it seems for us to be a way of optimizing the situation. It provides additional flexibility, so we can do like channel-based selection of the provider. We can also do the same for based on the subscriber. There is a typo that it should be subscriber-based and subscribe-based upstream selection. Of course, that involves an additional complexity over current MLD proxy, because we have to handle the control messages in upstream and downstream to be able to select the right upstream interface, and the same thing for the actual multicast data to provide from the right upstream content provider. And the purpose of the document, as I mentioned before, is to identify the actual requirements if we go to this extension, and then the next step after that will be to specify the solution. Next, please. In the current draft, we consider different scenarios for fixed multicast delivery, and I highlight here fixed because before we also had some mobility-based use cases, but we decided to remove those for the current version just to make it simpler and easier to follow. The three cases that we have is, one is the multicast wholesale offer for residential services. Basically here the idea is to have multiple content providers, maybe because we have the incumbent operator and we want to support alternative ones. And the idea is to support this MLD proxy to select the best option based on different criteria. Another one is multicast resiliency. So basically you may want to have like a fallback solution in case your default upstream provider falls. So you want to have like one upstream, and then if something happens, move to a different one. Another related use case will be load balancing. In this case, you want to keep more than one active at the same time, and maybe you want to balance the load. And of course, the benefits of having multiple upstream interfaces that you have, you will be able to make a better use of the resources on your network. And you will do that reducing the complexity, or avoiding the complexity of doing the same thing with multicast routing protocols in the access aggregation devices. Next, please. I'm not going to go into all the details. We have already quite a long discussion, so I think I hope you are not exhausted by now. So I will avoid these details, but the idea is that in the document, based on these different use cases, we identify some more concrete requirements that the MLD with multiple upstream interfaces will have to support. So for example, in case we want to have a resiliency, of course we have to be able to activate or deactivate the upstream interface, or the use of the interface based on whatever criteria. And well, there are a few other requirements identified in the document. So next, please, which should be the last. So our proposal for next steps, of course, is to get comments and to see if people are interested on working on this. And the idea is to, if there is such an interest, to see whether the working group will consider this as part of the rechartering process. If that was the case, then this document could be considered as an initial input for a requirements document, and then start working on a solution as part of the working group work. So that's it. Any question, comments?
From Cisco. Got a question. If you have two different upstream providers for the multicast transport, do you expect them both to use the same multicast group for the same content?
In the first scenario, in the wholesale, we are assuming different content, so it's for providing different content. But on the on the load balancing, for example, you can assume also having the same.
Because there's always the chance that two different providers pick the same multicast group for different content. And what do you do now, right? So it's.
How do you know
have you thought about that?
Yeah, well, that will be part of the extensions that we identify in the document. That's one of the extensions that you will need to have. I mean, you need something to know which is the content that each of them provides in order to be able to decide which upstream interface you are using for the
because
content. Yeah.
If you selectively want to pull the content from a particular provider, then SSM is the better way to do it, right? Because you then can select based on the source and you're not depending on the group address.
Yeah, I mean, we are not. The idea of this document is that this is not adding new functionality over what you can do with multicast routing protocol. It's trying to, for some particular scenarios, to avoid the complexity of having that multicast routing protocol on the access network. But it's not trying to replace that functionality.
Yeah, so just one quick comment. So I think when proxies were discussed a long time ago in Magma, it was decided to not consider multiple upstream interfaces, and the main problem is like, what if you get like a loop or something like that? So I think the main idea is find other like safe ways to do this, like certain restrictions, like filtering on maybe source or group addresses or other ways, so we can do this in a safe way.
Still Tali Secord. Is there any, sorry, I didn't get around reading that, but is there actually any, RPF selection for SSM in terms of that you are selecting the upstream interface purely from what, unicast routing tells you is for the source, the upstream interface?
So, I mean, I don't know if I got your question right. This trying just to, there is no solution work on this draft. This is only for the requirements. So the trying to see what there is interest in working on these extensions, but we are not doing any actual solution work on this draft.
Okay, I can rephrase that. So one requirement is to make, upstream interface selection based on available unicast routing in the case of SSM.
Okay.
Trying to understand the problem. Is it so that the proxy router can make a decision which upstream interface to use? So is that a purely local decision?
Pure, sorry? Pure what?
Is that a purely local decision?
We don't, I mean, this is open. I mean, we can consider having the discussion and the decision purely local or getting other information. I mean, we didn't get into that because it's just trying to identify requirements, not really going to solutions. So that will be part of the solution discussion if we go that way. So that's maybe the case.
Okay.
Yeah, so at least a comment I have, I guess, is there's been discussions in HomeNet, and also that was presented in this working group last time, but they also had this problem with multiple, at least two providers, and they were saying, okay, we maybe just join the same group to both providers and just see which one we get traffic from, and somehow decide which one to prefer if they got from both. And all the open questions, at least for ASM, is where do you join? You don't know necessarily which provider offers which group. So you can make a local decision, but at least in a home, the home user doesn't know which groups maybe comes from which provider and things like that. You could have things like, I don't know, DHCP options, other way a proxy could maybe learn from a provider what groups to join from that provider or something. But at least for SSM, it's actually easy, or it depends. With SSM, if you have routing information, you could use that. In the HomeNet case, though, that was discussed, it was just like a home having basically a default route to both providers, and then you don't really know what to do for SSM either. But yeah, I think I don't know, the main thing, I suppose, is do the working group want to explore this work further, find out what are the requirements? So there's a lot of things that could be added to the document. The question is whether we actually want to work on it, I think. So.
And in fact, with the proposed recharter text, this type of work would be included in what would be under our scope. At least I think so, under what I just highlighted there. So not talking about this particular draft, but I think this work would be in scope. Speak up if you don't think that's the case. We haven't heard any people having problems with that so far, so okay. Okay. You're dying to talk. Oh, okay, so, all right, let's maybe call for the, what would you like to see done? What are you asking again? I can't. Okay, so we'll ask the room then. So you would like to see it be adopted by this working group? Okay, so by show of hands, who would like to see this work that Carlos has just presented be done here in the PAM working group? Carlos, I'll assume that you raised your hand as well, so we've got 4. All right, so who would not like to see this be done in the working group? I don't know if I worded that right, but I think you get the point. So, okay, then we'll take it to the list, but so far we seem to have something that Alvaro is going to say.
Yeah, Alvaro San Francisco. All I want to say is that Carlos is bringing requirements, right? And I think what he really wants is not to work on the requirements, but to actually work on a solution. So I think an important question is not only who wants to see the requirements, but who actually wants to work on a solution. Because otherwise we end up with a requirements draft and nothing. And I think we're probably in the business of solving problems, right? Not on defining problems.
So I guess one question is, how well do we understand the requirements? Do we need to, spend time?
Yeah, and I have to admit,
So not just how much do you understand the requirements, but who's actually willing to work on the solution?
Hit him. No, sorry, and I answered actually the question that Alvaro was asking, right? Working on the solution. So, and what I said about SSM, I think with IGMP that would be the most simple solution, for example, for multicast and HomeNet, and that was basically the use case I'm interested in, and I think it would be nice to have that all the way through to the solution.
Can I just start my presentation from now? It's not in the agenda, but I already sent my slide regarding the solution of this kind of issue. And actually, we already discussed about the requirement and the solution in multi-mobile more than 2 years ago. And we had a discussion, some lightweight discussion of the requirement of multiple interface support for IGMP embedded proxy, and then we tend to provide some solution, and now is the time to start a discussion about the requirement as well as a solution.
What do you think? So you're asking for like another 10 minutes right now to discuss your draft. So let's make the working group decide. We're kind of, I don't know. Everybody's getting hungry, but so who was raise your hand if you don't want to hear any more conversations. No, I mean seriously, it's not on the agenda, so we have no obligation to have you go present right now.
What we can do is, I don't know, we can sort of officially end the meeting, and then people that are interested can stay here and watch the presentation.
That's a good call.
Lenny, did you have some comments before we end the meeting, or?
Yeah, just a quick plug for MBOND. We had our goal. We did in Hawaii. We did a joint MBOND and PIM working group meeting. We discovered there wasn't enough time for both, so we wanted to do concurrent or consecutive meetings, and we're doing that. So just a reminder: after lunch, come on back here, same room, same everything, and some of the topics will be similar, including to follow along with the question of exploring multicast routing protocols and alternatives to PIM. What should those requirements be in the modern era? In 2015, should we continue dragging the albatross of things like bursty source and source discovery, or should we begin to look at new requirements that are more pertinent and less obsolete for new multicast routing protocols? So we'd love to see you all join us for that conversation. If you had fun here, you're going to have a great time there.
Yeah, so I was going to say we generally let everyone come and present, but we really want people to, ask for agenda slots and give us slides before the meeting and so on. So I think that's why we're ending the meeting now. Thanks for everyone for coming. But if you're interested in watching the last presentation, feel free to stay here. Thanks. Okay, can we find the slides? Okay. Okay, Hitachi, we got your slides.
I think everybody's going to be, I don't know. We'll see what happens. You know what? I don't think it's going to work.
Let's see. No, some people are staying. Yeah.
Do you want to present or no?
No, the half the room is still here, so just do it quick if you want to.
Yeah, that'd be good. Sorry, hold this up quiet for a room like that. Just give me a second.
So I'm a little bit, unsure, asking. It's clear that the work, I think it's pretty clear that, there's interest in doing this. But how to structure it with requirements versus solutions and what we need is not completely clear to me. But if you do a detailed requirements document, then we almost have to talk about solutions to some extent. I know. We'll see.
So, next.
I mean, for instance, if you say we want to support SSM by filtering based on unicast routing and based on the source information, then they're already saying enough actually to, you don't need a separate solution almost for that, because that's all there is to say, kind of.
We'll just read that.
Well, I guess we'll just kind of keep adding detail to the document we have, and then we can see at some point, is this enough detail? Do we need solutions documents, or is this all we need to do? Or should we keep the requirements at kind of a bit more abstract level, kind of? But let's see. Okay, shall we? Yeah, I think that's just as well, really.
They're all happy. Yeah, okay. I think that's
sorry. I feel a bit bad about it, but yeah, really want to have an agenda and slides before, so people have a chance to see that. But I would say though, I think a first step would be to have something on the charter to work in this area, and then
Good to see you, man. How's the Juniper world? Still there? Yeah, you are.
Juniper, yeah.
People don't move around there as much as other places?
Not so much. No, especially where I am in the Westford office, not too many. It's not like Western Massachusetts.
Oh, you are?
Yeah.
Okay. There's an actual office.
Yeah, there's an office there. So it's not like we're in, Silicon Valley.
Right. You're not, yeah, exactly. Got it.
So Juniper's a pretty good gig for that area.
Yeah.
So guys get there and it ends up being a pretty good gig. So
research?
It's everything, it's like, they have everything. So they don't really break it up by area. It's kind of like everyone is international, so the whole group is international.
Oh, that's cool. Yeah, good for you. You guys working out. How long have you been there?
I've been there about 5 years now. I used to be an Avicii guy, if you remember Avicii.
Yeah, sure do. What is Avicii?
They're a core router. They kind of they disappeared. They tried to reinvent themselves as a company called Soapstone, which was kind of like an SDN company before SDN.
Right.
A little early to that party. Like PBT, if you remember that technology, that was like a Nortel type technology. So they're like the controller for PBT. that reinvention didn't work out, so that company went under. I was there the day they told us, go home and don't come back. That sucks. And it was surreal sitting there. It's like you spent 10 years in the company, and like, all right, that's it.
And that's all you
Party's
get.
over.
It's like, no, thanks a lot for all your hard work.
Yeah. Yeah, here's your little folder.
Exactly.
Now get out of here.
Yeah, I think that's why I have, after Cisco, I have zero problems. They have no allegiance to me, and I have no loyalty about them. So I'm definitely in that ADD world. I'll move around.
So how's it going at Ericsson?
It's going pretty well. I mean, it's I'm in this new group which I actually am enjoying. It's an SDN group. It's an SDN product development group. So it's actually kind of cool because it's actually working on the innovation development side that feeds into the laptop. So it's actually kind of cool. There's a big reorg that happened earlier this year, and I was going through it. It's not bad.
Good. Still focus on multicast, which multicast in the rear view mirror?
It's definitely the rear view mirror, yeah. But it does come up once in a while, because I am working on ONOS. Are you pretty much heard of ONOS? ONOS, Open Networking Operating System?
No, I don't know that area too well.
Yeah. So ONOS is kind of an alternative to Open Daylight. Open Daylight is probably the most successful piece of control right now, and ONOS is trying to, so Ericsson and Cisco and Huawei and everybody, it's come out of the ON Labs, which is basically it's this new effort for open source and control. And Multicast just came up with that. So every once in a while things come up. In this case, it was with DirecTV. Their use of multicast.
Since no one knows about it, it's like, hey, you know
exactly, right.
Explain all this stuff.
So that's about as much of it. But otherwise, I'm on more of the innovation side, and it's mostly SDN and NFTP. Cloud.
It's a hot area, so it's a good area
It's fun, yeah, exactly.
I think. So sorry to pull my presentation. I'd be curious on your thoughts. It seems like you might have some concerns with it, but
yeah. By the way, so I tried to update our agenda slides, but somehow even my new version still had your thing on the agenda.
Oh, really? The online one?
Yeah, but it's gone now. I managed to upload a new one.
Okay.
Just now during the meeting, or?
Yeah.
Okay, good. All right.
But yesterday, I don't know, it was gone from my presentation, and I uploaded it, but when I tried to download again, it was still the old version.
Are these new drafts? Or?
It's gone.
Yeah, brand new drafts. We got them right at the deadline.
I see. Are they, do you intend them to maybe come in here? Or?
Yeah.
Just not ready yet.
Yeah, we weren't ready yet. So for the next IETF, we're hoping to touch them up a little bit, get a presentation in order.
But I would say the comments from me is mainly things I just, are worth thinking about when we're discussing.
Right.
The main concern, the only one really big concern I have, I think, is for the Lasta routers. If there's, hundreds of thousands of Lasta routers or potential Lasta routers, there to be a lot of TCP states.
Yeah, so that is usually what folks as the first thing comes up. I mean, our idea was to use any cast RP, so separate the load and create it. And we have talked about we have investigated what modern day routers can support as far as TCP sessions, comparing with LDP and BGP, and usually they can handle in the thousands. So so there is we understand that concern. So we'll try to maybe even talk about it in the draft and maybe make it a discussion point in the presentation because
otherwise I can guarantee
right. And we don't want people to throw the idea out right away, I mean,
I get that too. If you try to address all those possible concerns in the draft, then it almost comes up as this is all. If you talk too much
that's one of the co-authors things, is maybe not bring it up.
Feel free to quote me again tomorrow.
I'll be in the beer. there's hidden problems in there that may, yeah. So, yeah, and there's different viewpoints on that. But we definitely want to go the Anycast RP route, just so like kind of like a hub and spoke type thing. There's like a hub network that have their connections, and then each RP can handle their locals, so that like this kind of distribute the load a little bit.
But I think that's something that's great to have. I don't know.
Yeah, I mean, we're hoping, yeah, I know there's a lot, this is definitely a Cisco working group, I mean, like every draft, so we're trying to make our inroads maybe into this working group.
I know it is, I know it is